All right, today we are going to talk about dividing polynomials. And we are actually going to use a skill that you probably haven't used for a long time, and that is long division. So, to kind of recap long division, take you back to your elementary school days most likely. We basically set up the formula so that you have your the first number divided by the second number. So some elementary teachers say like, oh, you put it in the house or whatever you think of, but you use the long division symbol. And then you would ask yourself, okay, I need to know how many times 14 goes into 2. Well, it doesn't. So the next thing I ask is, well, does 14 go into 25? It does, not evenly, but it does. So 14 goes into 25 one time. So then we would do 1 times 14 and get 14. And we stack that right under 25 and then we subtract. So if we do 25 minus 14, we get 11. Then we have to bring down the next number, which is a 2. So then we ask ourselves, how many times does 14 go into 112? And it's 8. So 8 comes after the 1. We do 8 times 14, and we actually do get 112. And then we subtract. And we get 0. Then we have to bring down this 0. And we ask ourselves, how many times does 14 go into 0? And that would be 0 times. 0 times 14 is 0. Subtract, you get a remainder of 0. So this worked out perfectly to 180. Sometimes it doesn't work out nice and perfect. For example, number 2, we're not going to get a nice pretty answer where we get 0 as our remainder. So we would set up our 24,024 divided by 5. 5 does not go into 2, but it does go into 24 4 times. 4 times 5 is 20. Subtract, you get 4. Bring down the 0. 5 does go into 40 8 times. 8 times 5 is 40. Subtract, you get 0. So then you bring down a 2. And you ask yourself, how many times does 5 go into 2? Well, it doesn't. So 0 times 5 is 0. Subtract, and then you bring down the 4. 5 goes into 24 4 times. 4 times 5 is 20. Subtract, you get 4. So the way you can present your answer is 4804 and 4/5. That is the same thing as saying 4804 plus 4/5. Or 4804 with a remainder of 4. That means we had 4 singles left over when we divide by 5. So if you had this much candy and you were sharing it evenly with 5 people, everybody would get this amount of candy, but there would be 4 pieces of candy left over. We can't evenly disperse those to the 5 people, so we just say, oh, we have 4 pieces left over. So you can choose any of these presentations for your answer. What we are going to do, because we're going to have X's in our answer, is we're going to use this presentation. All right, and then just reviewing dividing letters. So one of the things I like to do is write it in fraction form. So I'm going to convert all of these to fraction form. And then I'm simply going to just use my exponent rules. So this is smaller, and we take it from the bigger. So that leaves me x squared in the numerator. 2 and 2 divides to make 1. This is smaller. Subtract it from the bigger. We get x to the first. This one's smaller. We subtract 2 from the exponent and we get 6x to the first. So then we make this a little bit trickier and we do what's called factorable division. And you'll see what I mean when we actually do it. So the first thing I'm going to do is set it up as a fraction. Put it all over x. What I want to do is factor the top any way that I can. So I see right off the bat there's a GCF of x. So I'm going to factor out an x. And that leaves me with x squared plus x minus 2. And that is still all over x. Once you factor either the numerator or the denominator, you may basically eliminate anything that's the same. So we can actually do x divided by x. That's just 1. So I'm left with simply x squared plus x minus 2. If I look at number 7 and take the same approach, I would take 2x squared plus 11x plus 15 and divide it all by 2x plus 5. So when it comes to polynomial division, you can't basically do any crossing out unless you have it factored. So the top would need to be factored in order to look for anything that's the same. So I need numbers that make 30 that also make 11, and 6 and 5 are definitely going to do that trick. So I can rewrite this as 2x squared plus 6x plus 5x plus 15. I can group it up. I get 2x and then x plus 3. I can factor out a 5. I get that x plus 3 that I need. And so the top actually factors into 2x plus 5 times the quantity x plus 3, and it's all over 2x plus 5. Now that the top is factored and everything's in parentheses, I may simplify anything that does appear in the denominator. So the 2x plus 5s basically can reduce with each other to get 1, and you're simply left with x plus 3. We need to make sure that we know the vocab, again, because we're going to be dividing things with letters, so it's important that we can all speak the same language. So the number that's being divided is called the dividend. The number who's doing the dividing is called the divisor. And then whatever you get as your answer, because it's a division problem, is called the quotient. Sometimes we have a remainder and sometimes we don't. So in this case, 10 divided by 2 is 5. You could also say it's 5 with a remainder of 0, meaning if you divvied 10 pieces of candy out between 2 people, everyone would get, or both people would get 5, and there would be no candy left over, so it works out perfectly. All right, so it works the same way with long division. So whoever's inside the symbol is the dividend. 14 is doing the dividing, so that's the divisor. Your quotient is going to be whatever's on top. So 14 goes into 167 11 times, but it has a remainder of 13. So you would have 13 if you shared 167 Skittles amongst 14 people. Everyone would get 11 pieces, and then you would have 13 pieces left over. So how does this tie into this topic? So we are going to learn 2 strategies. One is called polynomial long division, and the other is called synthetic division. Both are annoying to say. Synthetic division is quicker to do, but it has stricter rules. Polynomial division works pretty much all the time, so they each have a little good and bad. So we're going to start by just identifying the steps, and then we'll actually put the steps to use. So regardless if you're doing synthetic or polynomial division, you need to put your dividend. So this would be the dividend. It needs to be in descending order. You need to use 0 if you're missing any terms. So for example, if you have x cubed plus x, you need to rewrite it as x cubed plus 0x squared plus x plus 0. So my powers should go in descending order: 3, 2, 1, none. So filling in those zeros is really important to staying organized and avoiding mistakes. All right, I don't have to worry about it with this one because I have degree 2 and then a 1 and then a none. So it's already in descending order. It won't always be like that. Polynomial division, once you put it in descending order, you're going to set up your long division and you're going to divide as you normally would. And it's actually easier to see and do together versus try to explain it. If we're doing synthetic, you're going to set your divisor equal to 0. And again, we'll go through those steps together so you can see each of them being used. Then we're going to draw an L. We're going to place the coefficients of the variables inside our L, and we're going to put our 0 outside. We're going to bring down the leading coefficient. We're going to do bottom times side, add and repeat. And when we're done, we're going to put our letters back in the problem, but all of our powers are going to decrease by 1. So again, I don't expect you to understand most of what I said. Once we pair it with an example, you can see each thing being applied and it'll make more sense. So we're going to start with the polynomial long division. So we're going to set up long division. It's already in descending order. We want to do 2x squared plus 11x plus 15 divided by x plus 3. So just like the very first problem when we did long division, we set it up. What we're trying to do is take this divided by that. So we do the first term divided by the first term. So 2x squared divided by x is going to get you 2x. Some people think, x times what gets you 2x squared? So some kids think of it like that, and they're like, oh, x times 2x gets you 2x squared. It doesn't matter how you think of it. Just make sure when you take this top item and multiply it by x, you do truly get whatever was here. They have to match up. But then you also have to do 2x times the 3, and that gets you 6x. So you want to make sure you stack your 6x under your 11x. You want to stack your columns nice and neatly. Okay, powers should go with matching powers. And then you would subtract, just like normal long division. The only difference is you have two things here, so you have to subtract each of them. These should always make 0. That's the whole point to doing that. 11 minus 6 is 5x. And then you bring down the next item, which is positive 15. And then we do the whole thing all over again. So we're thinking x times what gets you 5x? And that would be 5. And then we do 5 times x, we get 5x. We do 5 times 3, and we get 15. Notice I'm stacking them nice and neatly. Subtract, subtract. These make 0, and conveniently, these make 0 as well. And up here is where your quotient is. So the answer to the problem is 2x plus 5. So it doesn't take long to get pretty accustomed to doing that, but it's very important that everything's in descending order. The setup is nice and pretty. You have space fillers if you need them, and you keep your columns straight. So organization does count. Synthetic division is actually a lot quicker, but there's only certain times you can apply it. So we're going to run through how to do it and then talk about when it's appropriate. So the first thing is make sure that dividend is in descending order, and it is. Right? 2, 1, none. Perfect. So then we move to step 2, and it says take your divisor, which is x plus 3, and set it equal to 0 and solve for x. So obviously x would equal negative 3. Alright, now there's something to be said for that. When you set something equal to 0 and solve, that's called finding a 0 of the polynomial. But here's the rule. This would need to be a factor of this in order for this to be a true 0. In other words, when I do this divided by this, I need a remainder of 0. If that happens, then negative 3 is a 0 of this polynomial. So we already did that with the long division. We know it's going to work out. So notice x plus 3 times 2x plus 5 gets you this polynomial. We just proved that when we did long division. That's what long division means. It means what times what gets me back to that answer. So these are the same thing. Well, if you plug negative 3 in for x, you're going to get an answer of 0. So that makes this polynomial 0. If you plug negative 5 halves in for x, you also get 0. So this is a 0 of this polynomial. So that's a little, I get that that's a little confusing to absorb right now, but just know that whenever you set a parenthesis equal to 0 and you solve it, you are finding a 0. Now we're going to pretend that we don't know that x plus 3 already works. So I don't know if you'll truly get a remainder of 0. So I call this my pretend 0. If I get a remainder of 0, I can call this a true 0 of the parabola. So next we're going to draw an L. And I'm going to do this over on the side. We're going to write the coefficients of our variables. So our coefficients are 2, 11, and 15. We're going to put those inside the L, just like this. We're going to put our 0 outside the L. So it was -3, that goes outside the L. We're going to bring down our leading coefficient, which is 2. We're going to bring that down first. We just drop it down underneath the L. We do 2 times -3, and we get -6. So I'm doing bottom times side, and I'm putting it under the next number. I'm going to add them, and I'm going to repeat that process. So 5 times -3, that is -15. And when I subtract them, I get 0. That is awesome. Whenever you get 0, that's good. That means, hey, this actually worked. Like, this goes into this evenly. Like, -3 actually does make this equal 0. That's the whole goal. Now, what you want to remember is that this was 2x squared, 11x, and the 15 was our constant. When you divide, you go down in value. So what was once x squared is now an x. And what was once an x is now a constant. And what was once a constant is now a remainder. So that means we're going to present our answer as 2x, 5, and a remainder of 0, which means we don't have to write anything. So x plus 3 goes into this polynomial 2x plus 5 times, which means -3 is a 0 of this polynomial. And if you want evidence, plug -3 in. If you were to plug -3 into the polynomial and simplify it, you're going to get 0. So if you get a remainder of 0, that means when you plug this number in, you're going to get 0 as an answer. Now, synthetic division is really nice. You can see the difference in workload. This is all the work you did for synthetic. This is all the work you did for long division. Obviously, synthetic is much quicker, much nicer. However, you can only use synthetic division under the following conditions. 1, your divisor has to be linear. So you were dividing by x plus 3 before, right? That is a line. If you're dividing by x squared plus 3, you can't use synthetic division. This is not linear, that's quadratic. You have to use long division. The second condition is your leading coefficient of your divisor has to be 1. So for example, x plus 3 is what we used before. That has a 1 in front of it. If I change that to 2x plus 3, I really don't want to use synthetic division anymore. We want to use long division. So those are the only conditions. Long division can be used for any scenario, so that's always your safety net.